Because my y's were opposite, when we added them together, they canceled out. And I only have 2x equals 14. What's x?
7.
Well, that's nifty.
No way.
Okay.
She did it. I am so mesmerized.
Be able to do that every time. This one was a pretty like straightforward one, right? Okay. So now, how do I get y? Colin?
You do that. Well, if x equals 7 and you with the x plus y.
Okay. So x is 7 plus y equals 10. What's y? So our coordinate is 7, 3. Ladies and gentlemen, this is what we call elimination. It sounds cool too. Elimination. Okay, so these are our steps. Okay, we want at least one pair of opposite coefficients. Okay, so one pair of like terms that has opposite coefficients. When you do that, then we can add our equations and one of our variables will be eliminated. Okay. We then have an equation that we can solve. And then we can substitute into one of the original equations. It is a beautiful thing. What is going on back here? Okay, so the first thing we're going to look for, do we have coefficients that are opposites? And if we have coefficients that are opposites, man, we can just go right to it. If we do not have coefficients that are opposites, and we want to use elimination, then we're going to have to force it. Okay, so let's just practice right now when they're already opposite. Are you ready? So let's turn to that next page. We're going to look at number 1 together. Okay, do we have a set of variables that are opposites?
Yeah.
Which variables? Okay, notice how my x's are already opposites. So what we can do is we can add these two equations together. Please put the plus and the equals line. Okay. What happens when we add x and negative x? Okay. We're going to get 0. Those are going to cancel out. Okay. What happens when we add 3y and 2y? We get 5y. And what happens when we add 17 and 8? 25. Okay. Now we're kind of getting to the point where you don't even have to show me that you divided both sides by 5. We can do that in our head. What's if 5y equals 25? What's 5? What's Yep, I said it in my question instead of asking my question. Okay. Okay. Now, Gavin, does it matter where I put 5 in for y, the first equation or the second equation? It doesn't matter. It is where these two intersect. If I put 5 in for the first equation, I should get the same y as when I put it into the second equation, if we did our math right. Okay, so which one do you want to vote for, the first or the second? Okay. I'd be more concerned about the coefficient for y. But so we have x. Oh, just kidding. No, we want to be more concerned about the coefficient for x. So yeah, let's not do negatives. So we have x plus 3y equals 17. You guys. I need you to write your answer as a coordinate. I'm not digging for the x and y in your work. You're going to write it as a coordinate. Now, it is very important that when we get an answer, we check to make sure our answer is correct. You don't even have to show work. What's 2 plus 3 times 5? 17. What's negative 2 plus 2 times 5? 8. We're good. That was my check mark. Okay, you can do the same thing. Look how excited he is for you. We did it. Math is so great. He's here. Because it's the holidays and I'm excited. Well, it started yesterday, so I'm ready for it. All right, let's look at number 2. In number 2, is there a pair of coefficients that are opposite? You all sound like toddlers. Why? Why?
I still be saying that.
You just shoved them into
Number
the
14.
Okay, so let's add these two together. How many x's do I have? 7x. When we add our y's together, hey, they cancel out. Not gonna worry about that. Okay, 5 plus 16. Guys, I love this method so much. Like,
I did too.
it's so great, doesn't it? Look, 7x equals 21. What does that mean? How about x equals 3?
Yeah.
My bad.
It won't. It's not the first time. It won't be the last time.
No, they're so close in the outside. I end up.
All right, now let's come back to one of the original equations. We're going to take a vote. How many of you would like to plug x equals 3 into the first equation? Second equation. Okay, I think the second equation is a good choice because we have a positive coefficient for y. It's going to save us a step. All right, so 5x plus y equals 16. Say it together, everyone. Y equals?
1.
Okay, let's check our work. Make sure we have an answer that makes sense. Is 2 times 3 minus 1, 5.
Yes.
Good. Is 5 times 3 plus 1, 16.
Maybe.
Yes.
Okay. Slide on over to number 3. Do we have opposite coefficients? All right, solve it for me. You can do it without me. Some of you have already started anyway. Are you okay?
Yeah.
And I would love it if you would compare answers with your neighbor. when you have one. Well, now I just don't know. Okay. How about we take your eyes up here. You're good. Okay, so pick one of these that you can plug 4 in for y. Negative 2x minus 4 equals negative 2. Then, yep, you can add 4. Yeah. There you go. Okay, Preston, what did you get when you added these together? 2y equals 8, which means y equals what? Colin, let's not. Okay. Okay. Hold it. Do you agree with y equals 4? It's a yes or no. Okay. So then Estelle, where did you put 4 into? Okay. So you have 2x plus 30y equals 10. What'd you get for x? So you're saying that these two lines intersect at the coordinate negative 1, 4.
Yeah.
No?
Yeah.
2 times negative 1 plus 3 times 4. Does that equal 10?
Yeah.
Okay, that's good. Negative 2 times negative 1 minus 4. Does that equal negative 2? All right. There's our intersection. All right, go ahead and turn the page. And we're going to look at number 10. Know what to do. Oh. We're not going to skip it. Okay, well, if we added them together, don't write this down, we would have 3x plus 3y equals 39. The whole point of elimination is that we eliminate a variable. So it's not going to work out right here because what is not true about our two?
We're not eliminating.
Okay, right. And why is that not happening? Okay, we don't have coefficients that are opposites, is what you just said. So what do we need?
Opposite coefficients.
We need opposite coefficients. Okay, so if this guy has a coefficient of 2, it would be really nice if this x had a coefficient of. Okay, so let's multiply this whole equation by negative 2. If I multiply negative 2 to both sides, I'm not changing anything. So we would have negative 2 times x, negative 2 times 2y, because I took negative 2 times 2y. So we have to multiply this to everything equals negative 40. That's beautiful, isn't it? Okay, so now watch this, Colin. Now I'm going to rewrite my second equation. Look, my x's are now opposites.
Why didn't we do the second?
Can you ask your question again?
Why did we do the first one but not the second one? Like,
Because if I multiplied this first one by -2, then my x's were opposites.
no, I was trying to like, why didn't we just keep the top one the same? We just do make negative the bottom one.
We could have done that. There's going to be a couple different ways we can go about doing this. As long as your x's or your y's are opposites, then we're ready for elimination. So I chose, because I saw the x's first, I chose to make my x's opposite. So I multiplied this first equation by -2. Now, every single thing got multiplied by -2. Now watch what happens when we add these together. What happens to my x's? But we have -3y equals -21. Yes, ma'am. So since this coefficient was a +2, I wanted this coefficient to be -2. Does that make sense?
Yeah.
Okay. Woohoo! The x's are eliminated. And what's y? Okay. Now where should I go? Does it matter? Doesn't matter. I'm going to go to the second one because it's going to be less algebra. No, it's not. The first one's going to be less algebra, isn't it? Yeah. X plus 2y equals 20. What does x equal?
6.
Yes. Let's check. Oh, we have to make sure we're right. Okay, isn't it nice knowing if you're right?
Yeah.
Why sign, Preston?
Hey, what is 6
That's a number.
plus 2 times 7?
What's this
A
plus
number.
14, Preston?
What is 2 times 6? What?
What?
I said 2 times 6.
He was talking about that first equation.
I was answering page.
So you were just a little late.
Yeah.
2 times 6 plus 7. So 12 plus 7 is 19. We're good. Okay. We're going to be a little bit crazy and we're going to go to number 12 next.
What about 11?
We'll come back.
Okay.
Okay. Okay, so first of all, I want you to look at number 12 and I want you to think about, what if I asked you to do substitution? This is not a very fun problem for substitution because whether you solve for an X or a Y, you're going to have fractions. So let's everyone appreciate for a moment our elimination method. Okay. Now, do you see opposites?
Yes, I do.
You do?
Where?
Opposites, like true opposites.
Nah.
Okay. So you see a +4 and a -10, but you don't see opposites of the same number. Okay. So this is what we need to do. We need to either force our x's to have opposite coefficients, or we need to force our y's to have opposite coefficients. Is there a right and a wrong way? No. Sometimes there's a more efficient way, but there's no right versus wrong here. I just want you to think about it. I want you to think about how we would make the x's opposite versus how we would make the y's opposite. And how about you just have a conversation with your neighbor about what you think's gonna work better?
You have to multiply by -9. You know,
Okay, raise your hand if you think we should make the y's opposite. Raise your hand if you think we should make the x's opposite. Okay, the x's is going to take less effort for us to make opposite. Okay, because if this is a 9x, what can I multiply this second one by? -3. Okay. So I'm going to rewrite 9x plus 4y equals 11. And if we multiply this second one by a -3, we would have -9x plus 30y equals a +6. Please make sure that -3 gets distributed to all 3 of your terms. This is so great. Are my x's opposite?
yeah.
Sure are, they go away. So I have 34y. Wait. Equals 17. Oh. We're gonna get a fraction. Okay, so let's all appreciate that 17 divided by 34, 17 is a smaller number. And if I have a smaller number getting divided by a bigger number, we're gonna have a fraction. Oh no, a fraction. Fractions are our friends. We are fine with fractions. All right. Let's go ahead and take our fraction friend. What do you think? First or second one, I guess? I'm gonna go the first one. Potato, potato, it doesn't matter. Okay, so if I punch it into this first one, we have 4 times 1/2. What is that?
2.
So 9x plus 2 equals 11.
I think it's 1. If you multiply 0
Yes,
by
I know.
Anna, it's by you, right? Guys, isn't this great?
No.
I really love elimination.
It's beautiful.
It is. Let's talk about number 11. Number 11. Oh. Okay. Do I have a pair of opposite coefficients?
No.
Not even close. So this is what we're just gonna have to pick. X's or Y's. They're both gonna be the same amount of work. Let's just pick X. Okay. In order to force these two to be opposite, we're going to have to multiply this first equation by 4 and this second equation by -3 because we need them to be opposites. Okay. Oh, great question. Elliot asked, could we do -4 and +3? Yep, sure could. As long as you get opposite coefficients. Okay. If I multiply this first equation by a +4, we are going to get 12x minus 8y equals -8. And if you're not writing that, you're not showing me enough work. If we multiply the second one by -3, we're going to get negative 12x plus 9y equals a positive 12. If you're not writing that down, you're not showing me enough work. The whole point in choosing 4 and -3 is so that we could get our x's to be positive. Now, some of you may have chosen 3 and -2 to make your y's opposite, okay? But we decided to go with our x's, okay? And when we do this, oh, this is so exciting. What's -8y plus 9y? And what does it equal? How excited Buddy is! We got y equals 4. Buddy the elf. It's okay.
He's staring into my soul.
It's okay if you haven't.
I'm not doing my podcast. Funny.
Probably not. All right. I don't know what to do with the 4. What do I do with y equals 4? Okay, so we have 3x minus 2y equals -2, like that. So 3x minus 8 is -2. What? Did I do that right? Oh yeah, 3x equals 6.
Yeah.
So Cade, what's x? So 3 times 2 is 6. Minus 2 times 4 is 8. That checks out. 4 times 2 is 8. Minus 3 times 4 is 12. That checks out. Okay. So this is what I think we're going to do with the last 9 minutes of class. Do some homework. Get your notebooks out. We're going to go ahead and start. What does your gold sheet say for homework? Three through 8 and 11 through 16. So you could start on 3 through 8. 3 through 8 are your favorite. Why is 3 through 8